still probably be piling in as we go forward, but I want to be able to cover everything. So we're going to start. So today we're going to talk about integration of feature flags and generative AI. Welcome to my talk. So it's feature flags and GenAI, parameterization, and experimentation. Those are kind of long words. Don't let that scare you away. So, oops, real quick. The wrong window here. There we go. So today there's going to be kind of five sections, although most of it is going to be in sections 1, 2, and 3. But basically the idea is we talk about a little bit of the history of and the sort of drivers for using feature flags, a little bit of the history of GenAI. I know that's like a super common topic, and a lot of talks have been about GenAI, including the keynotes earlier yesterday, for example. But I want to make sure everyone's kind of on the same page with where I'm coming from, at least on this talk. So there's going to be a little bit of that. A discussion of parameterization, basically controlling your AI features from using your feature flagging system as a remote configuration store. And then also a little bit of talk of some concepts that are key to using experiments and experimenting with features, and especially relevant, of course, to experimenting with generative AI features as well. And then there's going to be some code examples throughout this. Sometimes there's going to be like a lot of code on the screen. I'm sorry for that, but I did want to have like real, actual examples that I have validated that actually work. And there'll be like little arrows pointing to kind of things that are relevant or that are important to pay attention to on that kind of block of code. And then there will be a brief discussion at the end of kind of a future outlook for other things to sort of that are on the horizon to kind of just be on the lookout for as you kind of do research and kind of work in your day-to-day. So some outcomes hopefully for the session, kind of if you aren't using feature flags and you're using GenAI tooling, or you are using if you're using feature flags and not GenAI tooling, or using GenAI tooling and not feature flags, think about using kind of both together. Kind of think about what you can use, some examples, and then, like I said, kind of a future outlook as sort of outcomes of this session. About me, so my name is Josh Klein. I am a senior integration advisor at Harness Software. I have 15 years of experience, software engineer, doing system integrations, integration engineer, solutions architect. I've had a kind of a couple of interesting industries that I worked in. I actually started off my career in serious games modeling and simulation. For those of you who are kind of familiar, like I tell my 8-year-old son that my first job was making video games, even though it's not technically true, but it was kind of cool. The company I worked for eventually got bought out by Bohemian Interactive, which is a company that's based in Prague. And so that's the closest. Unfortunately, I never ended up getting to go there, but this is the first time I've been in Eastern Europe, or Northern Eastern Europe, I guess. I also spent some time in like HRIS, like HR software. I worked at a company that was partnered with SAP, so I got to kind of see in the bowels of these huge enterprise Java systems, which was pretty cool. And then right now I work at Harness. I actually worked at Split Software before they were bought by Harness. So Split Software is a feature flagging vendor. So we do like feature flags and feature management and experimentation. And so Split was bought by Harness, so now I work for Harness. So some sort of context for why you would want to use feature flags, like why and how could they interact within like sort of an AI-based code that's using AI or AI-based code and tooling. So for those who may not be super familiar with feature flagging, or maybe haven't used them at all, so what is a feature flag? Feature flag is to control a feature release. That's in the name. Sometimes also called a feature toggle. The sort of key, light bulb moment for feature flagging is allowing you to separate the deploy of code from the release of a feature. The idea is that you can continually run CI/CD pipelines, continue to deliver code, continuous delivery, and separate the release of features from the release of code, right? That's like feature flagging 101. That allows for what's called trunk-based development, which means that instead of releasing new features based upon merging branches, and then let's say you have a feature branch where you have either a single person or a team developing a feature inside of that branch, then you merge the branch into production, and then that releases the feature, right? That's branch. That's like really common without feature flags. That's kind of branching-based development, and that, you end up having a number of branches. You have branches for each feature. You maybe have long-lived branches, then you have to merge them, and it becomes sort of a real pain in the butt to have to merge a bunch of different features. People call that merge hell. It's terrible. I've lived it. And so using feature flags allows you to continually release from the main branch, and features that are under development are hidden by feature flags. Again, this is like sort of the core motivation for using feature flags. Feature flags also allow you to sort of test in production. What that means is that instead of having a separate test instance and then a separate production instance, you basically deploy the code to production, like I was talking about earlier with the trunk-based development and the CI/CD pipelines. You're continuously deploying code to production. When you do that, the feature itself can be released in a controlled release, like a percentage-based release, or a release to like a QA team with specific individual targeting. And the idea here is that ultimately a test or development instance is going to be different from production, right? And so there are inevitably bugs that happen when, something goes down in production. Well, it didn't happen in test. That's a common thing that happens all the time. And the idea is that if you test in production, you're testing with actual real live systems and real live data. This is especially also relevant for some industries that are regulated to the point where you can't actually bring that data into, you can't bring PII into a test system, right? So you can figure out how to test in production there without having to do that. And so there are definitely other, those are some of the advantages of being able to test in production. For those of you who may or may not be familiar with sort of the more broader lean and DevOps movement, this book, Accelerate, is excellent. I've read it from cover to cover. It has a lot of information about, like, if you've ever read the Phoenix Project, these basically the idea is that continually release, like continue to release features and kind of keep software being built. Like, don't bunch up work. Don't it's flowed. I mean, there's all these lean and Kanban practitioners. If you're familiar with, if you've gone to like a Agile or a Scrum type conference, I mean, there's sessions all day about this kind of stuff. But there are a couple case studies that are interesting if you've read them. Spotify and ING are two companies that have done total transformations with respect to lean and agile style development. It's pretty cool stuff. I'm not going to go into super details with them, but it's just interesting to note that they've seen a lot of advantages on the speed and quality of the software releases by moving to sort of a lean DevOps model. But again, I'm not going to go into super detailed about that, but we can kind of go back into our feature flags and talk about, so we've talked a little bit about feature flags themselves, and then we can talk about kind of the types of feature flags, right? So we talked about released feature flags, basically a piece of code that you're going to release or that has been planned to release, and the idea is that you're going to control that release, either to, let's say, starting with a QA team or possibly starting rolling out to a percentage of your users in production to kind of measure and see if it's going to cause any problems. Let's say you don't want to release a feature and then have it kill your API response rate or something, or have it drastically increase the load time of your app, which is something you don't want to do. It's maybe you didn't see that in test for some reason. That's like a release feature flag. There are also experiment feature flags, which are kind of probably going to be more common in the AI use case, or the GenAI LLM use case. Those are ones where, let's say, either an ML scientist or a product manager is interested in seeing if a certain change to your LLM parameters goes to, let's say, and I'll have a couple examples of this too. Let's say you have as part of your pipeline for your LLM or your generative AI, it produces an image, and you're making a 512 by 512, but that can be kind of expensive. Let's say you want to reduce it to 384 by 512. Does that change the user's behavior? Does that make them less likely to, to stay on your page, to interact with, let's say it's an AI avatar, or to click on a link, right? That's kind of an experiment where it's something that you're not sure if it's going to ultimately make a significant change, but you want to find out. And then there are other kinds of flags. For the first two, those are flags that end up getting removed at the end of the day after, for example, the first one, after you've done the release, you remove the flag. After you've done the experiment and you have your data that you need, you remove the flag. The other two are like ops toggles or permissions. An ops toggle is like more like which server are you routing requests to, or are you turning on or turning off a certain functionality that's core in your backend. You may end up removing that as you like re-platform at some point, but that's not like designed to be removed. And then permissions, like these two use cases on the bottom two are less common, and oftentimes there are like specific, like for example, you'll often see like specific permission software, though we have seen like permissions as a feature flag use case, though it's not super common. Like you want to give certain functionality to users who pay more, or like who have like a different membership, like gold or platinum on whatever sort of platform or service that you're building. We've seen that, although the first two are pretty much the most common ones, and kind of fit kind of the most in the broad feature flag use case. So as part of like a DevOps transformation that some of these companies are doing, these companies have seen like real significant change. So some of the things that was interesting, I was looking at the data that came out here. This is 2017 data from Accelerate, because the book is it's 7 years old now. I think it's still pretty relevant in a lot of ways. But sort of as conceptually to think about how these sort of high performers are, how they are seeing things, right? So if you're not deploying on demand, if you're not, if your time for changes when you click the button to commit to production to when it's rolled out is, medium or low performers are seeing that to like a week or a month. If production goes down, it takes less than an hour to recover. These are interesting statistics and allow you to kind of measure where your organization, your team, your company, where you're at with your DevOps journey and compare to the leaders in the field. And this is good stuff. This is available for free on Google's Dora.dev page. This is not fully a DevOps talk or a lean talk really, but I like this stuff. I find this stuff really interesting and really important. So it's interesting to sort of, and they have like a little quiz on the page too, where you can kind of take stock of where your team is, right? Like based upon the industry you're in and based upon, you can, estimate this data, right? The last time. It's interesting too, because in 2023, the biggest change really was that the change failure rate went down a lot. So for these high performers, like 95% of the times they make a change in production, it works. Whereas the low performers from 7 years ago was like almost a third to a half of the time that they made a change to production, they had to roll it back. And so that's enormously costly. And so feature flags, which are a core component of sort of a DevOps implementation or a DevOps strategy, significantly reduces costs in a lot of ways and increases like the quality of code released. So yeah, I talked a little bit about this earlier. Google's DevOps Research and Assessment, their sort of DORA group, they like basically survey 36,000 professionals, and it's freely available on Dora.dev, and sort of the quote here where they talk about the importance of feature flags or feature toggles. This is the kind of dark launch, which is the release feature flag. So check out Dora.dev, it's pretty cool. So what about AI? Yeah, let's talk about it. So history of AI, I'm not going to spend too much detail on this because I'm sure there are a ton of talks that talk about this, and I saw them too, which is cool. But like, AI has been researched as part of computer science since the 1950s. Long-term goal has always been to have computers think like humans, right? And then one of the talks earlier was like, had a nice book that was like, well, the AI that we have now, AI is really just like a parrot. It doesn't like understand anything, right? And so it started with like truth tables or truth trees, and like how do you get from there to actual words? I'm just kind of throwing out words at you too, right? Like, so if you have like, then they looked at Markov chain and neural networks, like a probabilistic chains of vowels and consonants, trying to figure out like, how to form sentences that make sense based upon the things that you're asking, right? If you were a software engineer in like the 2000s, like 2009, 10, 11, 12, like machine learning was popular, ML, and it's obviously still getting more popular along with deep learning and neural networks. But the big As everyone saw, like the big change or the big sort of explosion was when GPT-3 came out, but also DALL-E in 2021, for those who were around then. That was huge. People were making funny images and like sort of amazed at that too. And this was interesting too that I saw, according to a GitHub survey, like 92% of developers today are using AI tools both in and out of work, right? So that's like an enormous change. That's something that's happened extremely rapidly over the last few years. Something interestingly, I also saw recently was that, sort of I have like 15 years of experience. I started professionally around 2009. I started my career, with researching all my questions on Stack Overflow. But I saw recently that the traffic to Stack Overflow has gone down significantly since ChatGPT was released, and that actually makes me a little sad because I liked, the culture on Stack Overflow could be a little contentious at times, but it was nice to know there was at least another human on the other side telling you that stuff. But I guess that's, the world is changing. There's a lot of talk about generative AI use cases and what actually, is profitable or makes sense, right? These things are really expensive and take a lot of compute and have to be run somewhere that takes a lot of power and a lot of water and a lot of electricity, right? So AI use cases in industry, everyone knows about the chatbots and virtual assistants. But there's other interesting stuff I saw too, like in manufacturing or legal contract generation or curriculum development for education. I actually have a friend of mine who's a teacher who speaks at education conferences and talks about using ChatGPT to help formulate education plans and worksheets for her students. Now I know on the opposite side, you don't really want the students just to feed it back into ChatGPT to get the answers, but there are ways to try to minimize that, like having the students do work in class. But anyway, one thing I thought that was interesting that I saw was Airbus actually has their mechanics using a sort of an LLM to ask questions to when they're working on airplanes, and I think that's a pretty good use case, right? So LLMs are ultimately text summarizers. That's where the technology kind of came from, and so this is like a perfect use case for that. So when a technician is trying to find the right wrench or right spanner, they can ask the AI rather than going through like a 500-page mechanical manual, which I think is kind of neat. Okay, so you know about AI now. You know about feature flags and their importance too. Why would you want to combine them, or what is kind of the sort of battle card for each, right? So in feature flags, the sort of persona is the software engineer, engineering manager, product manager, SRE, DevOps. Primarily, feature flags allow you to release safely, deploy strategically. You have like fast rollbacks if something goes wrong, and ultimately separating code from release, right? So this is important use case for feature flags. Feature flags allow you to deliver software faster. That is their core value, right? You want to deliver software faster. I mean, you deliver software safely too, but feature flags primarily allow you to deliver software faster. You get it in front of people faster, release it faster, roll it back faster, sort of remove a lot of steps from that chain. AI is a little different. Of course, the PMs and software engineers too are in AI, although the sort of software engineers are often, implementing AI, but it's like the ML scientists or ML engineers who are doing like the research on it and the experimentation. And AI is, automate tasks, enhance user experience, but like AI is for smarter features, intelligent features, like features that wow customers, right? It's sort of a very different sort of use case here, very different, like, what are you trying to do? What is this team trying to do? Why are we using this functionality, this tool, right? Using a feature flag as a tool, you want to get software out, you want to get it safely out there. If it's failing, you want to revert it. Whereas like an AI or LLM or a chatbot or whatever sort of machine learning backed feature you're building there, it's to make something smarter, to make something cooler, to make something that will increase increase profitability, increase value. And so there's kind of two things here, and how do we combine them, or what are some use cases or some examples of how you can combine them? So again, I talked about I'm kind of a little sorry about this, but I do want to, talk about like real, actual, live working code. So here's an example of stable diffusion code in Python. And one thing you'll note here is that there's a prompt, a superstar engineer, and there's a little extra text variable in a futuristic fantasy world. Like this is basically a prompt to build an image, right? There's some parameters here. Let's see, does this have a laser pointer? Yes, it does. So stable diffusion is the model. This is the prompt. This is the resolution. And the idea is basically to generate an image based upon the prompt, one image with the resolution at the resolution, right? So I think this is hopefully readable enough for folks, hopefully in the back too. But one thing you'll note here is that everything here is hard-coded. You can't, if you release this, let's say you want to change something, right? I want to change the prompt, I want to change the resolution, I want to change the AI model. You have to release, again, you have to deploy new code to do that. And if you want to rapidly iterate, that's going to be a pain in the butt to have to, if you've got an ML scientist who wants to, well, I want to maybe look at different models or weighting or something. And it's like, well, the ML scientist has to make those changes and deploy them, but then it has to be, measured as well. And then you can't like sort of have a A/B comparison between the two. Like, so what if you put that behind a feature flag? Let's say we have a feature flag, use stable diffusion 15 or 1.5, because I want to compare using two different AI models. And so now, yeah, cool. So now I have that here in this if statement, and I set the model name, and I pass the model name in here. And so now if I can control this via a variable, and then I can set this variable via the feature flagging system. And so that's kind of where we start here, and there are lots of like sort of other things to think about when doing this kind of thing. And so that's kind of where we start with parameterization section 2, making changes on the fly. So for those of you who have used AI models, who've experimented with like ChatGPT or OpenAI's API, or who have built a retrieval augmented generation, a RAG system, maybe you've done it for fun, maybe you've done it for work. There's a ton of stuff here that like, I'm a software engineer, I'm not an ML scientist, I don't know how I should do chunking. I'll just put a number in there, or I don't know what embeddings model to use. I'm not like, I don't have a PhD in machine learning. I'm just going to pick an embeddings model and see what it does. So there's lots of things you can experiment with, right? So there's not just the AI model, there's the prompt. Again, you're going to pick a prompt that you think makes sense, but you might not, know exactly how to fine tune it necessarily. The temperature for the AI model, right? This is kind of like a real woo thing, right? The temperature is how creative the AI model is, or at least that's what OpenAI's docs say. So, do you want it to be like really loopy, or do you want it to be very sort of deterministic and formal about things? The number of tokens to retrieve, like how big you want your response to be. This is sort of more ML stuff. The batch size. How many? If you're doing your the batch size of the returned value from the machine learning model, or the activation function. So my understanding is that activation function is basically in a neural network, individual neurons, to activate them, you can choose an activation function to do that, right? And so there's a ton of stuff that goes into these that you may want to experiment with based upon cost, based upon seeing if model changes the results. Let's say you want to experiment with all of these, right? So let's kind of explore some things that we can do here to make this easy and make this rapidly deployable and repeatable, and iterable. Whoops, got to move a little further. So here is like I said, I work for Split, and then it was acquired by Harness. So the examples inside the feature flagging system I'm going to use are Splits, but any sort of most modern feature flagging systems have this kind of ability. If you're not using one, of course I would say go check Split out, but really go check out any sort of one in the industry should have something like this. Basically, turning the treatment on or off can associate it with a JSON set of key value pairs, right? So in this case, we're setting a model name key to a value Stable Diffusion 1.5 or off 1.4, right? So now I'm not using this, I'm not setting this in the code, I'm actually setting the AI model in my feature flagging system itself and using it kind of as a remote parameter store. So now what I can do here is, right here, yeah. So let's say I've already initiated my feature flagging client. In this case, it's the split client. And what I'm doing is I'm calling get treatment with config. So I'm pulling that JSON down too. And so I call that this model raw config. And this model raw config I have to basically parse as JSON, and I have to do some defensive programming here just in case it's not there, of course. But if I've got this model name, I set it here. And so now I pass this model name into my function, and I've sort of abstracted the actual model name away so I can control that without having to deploy new code. So now what I can do is I can change the AI model without having to deploy new code. And I can sort of measure how that compares to the existing AI model that I was using. I've got a fall through just in case, for whatever reason, the feature flag client fails. But I've also got it defined here as Stable Diffusion 1.4. So what I can do with this is I can actually compare and do an A/B test and compare these two AI models together for things like how much is it costing me? Does using the more advanced AI model actually increase anything? Does it increase any of my metrics? Does it improve retention or time on the page? Or does it reduce the does it increase cart size? Depending on sort of your industry, you'd have different metrics, or depending on what application you're working on, you would have different metrics. But you can build those metrics and compare, basically. And so another thing you can do is you can set up multiple of these parameters inside an individual feature flag treatment. You can kind of call it a parameterization set, essentially, right? So it's a collection of properties. And you can sort of tune and measure these at an individual set level. So if a user, if you call your feature flagging system and you want to experiment with, let's say you do, like a 50-50, right? And so you give users a standard treatment, and your standard treatment, uses GPT 3.5 Turbo with a 0.5 temperature and 2,000 tokens. And then some other folks get a slightly reduced temperature and fewer tokens. Seeing if that reduced temperature and reduced tokens, does that change? Does that keep people on the page less because it's less interesting and there are fewer tokens and lower temperature? Does it not matter because it's going to be a little cheaper because there are fewer tokens? Those are the kind of things that you can measure and experiment with, right? But when you do that, you do have to note that sort of all of these are bound together. So you might not know if it's the temperature or the tokens that are causing that change because they're bound together in sort of one collection of parameters, right, a set of them. And so here's ChatGPT's API in Python, basically calling a feature flag, again, the get treatment with config function here. This is actually JavaScript as opposed to Python, so I'm an equal opportunity here with these scripting languages. But the idea here is then that you basically pull that out of the JSON and you pass that into the OpenAI API. And so now I've got all this information and it's sort of dynamically changeable here. And I can sort of continue to iterate here without having to deploy new code. As long as I've got enough traffic to power the experiments, I can kind of continually do this, and the software engineers don't have to deploy anything. I'm an ML scientist. I'm here hacking away, trying experimenting with different models, different parameters here. As long as this code is hooked up, I don't care what the software engineers do, right? I'm just working on testing my AI model, so it's interesting stuff. You can also do one flag per sort of parameter. It's kind of more like a normal feature flag. Basically what that would mean is like you'd have a flag for like back here you'd have a flag for for example, this flag is called model name, so you'd have a flag for like model name and a flag for temperature and a flag for max tokens, right? So you have more feature flags. What that does mean is that means it does mean you get metrics on each individual parameter, which is kind of nice. So you can like say, well, was it the temperature that did it, or was it the number of tokens? And if using the one flag per feature, it's kind of lets you do that. As long as you've got the enough power and the right statistical measures, you can sort of measure each one individually. The sets are kind of good when the ML/AI engineers are separated because you can kind of tune these parameters together. And there's also less technical debt, right? So I haven't talked about that. This comes up a lot at feature flag talks I do. The first question people ask is, how do I handle the feature flag debt, right? It's something that you do have to be aware of, right? Because you can't just keep leaving feature flags in the system, and pretty soon you have 800 or 1,000 feature flags and all these if statements scattered throughout your code, and that's a legitimate problem, right? So if you're concerned about tech debt, then kind of grouping them together may make more sense, kind of thinking about it. If you're able to, I mean, everyone should be concerned about tech debt, but it's more like there are problems in your organization that keep you from being able to rapidly reduce tech debt as it comes up. If you're in one of those style of organizations, having fewer flags might just make more sense and be more practical. If you're able to have like an individual flag per parameter, that does open some more interesting experimentation options, but it does make things a little bit more active in the code base and require more collaboration between software engineers and the folks doing ML stuff. All right, so experimentation. So let's talk about how to manage the data or how to think about it, which is interesting stuff also. So here's the common experimentation style, right? So you have an ideation. Someone in the product management or ML side has an idea. Let's develop a hypothesis or a test. Let's test X, Y, or Z, right? So the engineers write the code. It gets deployed, they measure it, and evaluate it, and try again, right? One of the things that can make this difficult is if you don't have feature flags, you're basically measuring, you have to handle like seasonality, you have to be like, how do I, basically you run the experiment for like a certain period of time, and if you don't have feature flags, then you're basically releasing it to everyone and comparing it to data that you didn't have, that you had before, and it's sort of, you have, like I said, problems potentially with seasonality, with the data not being the same. It's not perfect. People do this. It can take a lot of time and can be kind of slow. So if you have feature flags, what you can do is your ideation, you wrap your code behind a flag, you deploy it and release it. And what happens is you can run an A/B test, like distribute the traffic 50-50 or, fit 5 to 95, for example. If it's very like contentious or very risky, you don't want to release it to 50% of your users. Maybe you release it to 5. And again, if you have enough power in your experiment, enough users hitting the flag, you can make it work. You can sort of see if it's going to cause problems or be great, right? Everyone wants their feature to be great. Not all features are great. But if it is, then you've done a great job. Or like at least the feature didn't break anything and you wanted to do it, or you needed to do it for some certain reason, which also happens, right? So, but anyway, I actually ran into an interesting talk by Ron Kohavi. If you guys aren't familiar with Ronnie Kohavi, he's kind of like the king of experimentation and measurement type stuff. And one of the talks he talked about how it can be challenging for product managers because they're often measured or evaluated on how many features they release, but they're never evaluated on if they measure a feature that loses money and they don't release it, they're not necessarily rewarded for that. So interesting talk on incentives. Yeah, Ron Kohavi is great if you haven't seen any of his talks. But anyway, back to this. You can basically see that you get right here behind a feature flag, your experimentation is a little bit more sensical because you can compare at the exact same time doing A/B like a 50-50. But if you have this dynamic configuration, like if you're using your feature flag system as a remote parameter store, now what you've done is you've shortened the cycle because you've got your idea for, okay, we want to test our AI system. We want to throw a bunch of parameters in there. We're not exactly sure which ones we want to use, but we want to be able to experiment with them. You put it behind a flag, you deploy the code, and then all of a sudden, you don't have to deploy again. You don't have to code again. You can just keep measuring, and the cycle is reduced pretty significantly here, because now you evaluate, measure, release, evaluate, measure, release, and the release doesn't have to go through a deploy process. It's just changing parameters in the feature flagging system. So that saves a bunch of time and allows for more rapid iteration. And so another thing I wanted to cover a little bit was that sometimes you'll see like, so I'm from the US, so of course state here is US state, but the idea here is that the first time you'll talk to someone who wants to experiment with something, they'll be like, well, I want to look at experimenting with these users in these states. And the thing is, you can't just like hard code users, because that's not statistically sound. What you end up having to do is you have to use randomized percentages. Like, you can still experiment with these users, but it's not like everyone's going to get on. You have to distribute that to a certain number of them. So just another thing to keep in mind, that does come up often from time to time. So another thing I want to talk about with experimentation is, so I think this is something that folks who have used APM tools, like if you've used Datadog or New Relic to check out, is performance degrading, is something going down. Datadog actually has its own sort of feature flagging system now, but like it's I think important to note that it's difficult to actually prove causality if you've got multiple flags doing percentage-based releases. This is something to think about, right? So if you're using a feature flag system, you have a bunch of 50-50 experiments going on, and then there's a change to one of them, or a new one's released within sort of rapid succession. You've got like 2 or 3 feature flags that are going out and starting an experiment, and something goes wrong. You can't really be sure which one it is or how it actually behaves, because not everyone's seeing the same features, not everyone's getting the same sort of code executing for them, right? So, multiple different flags with each potential effects. How do you measure them independently? So the way to think about this is, if a user encounters a flag, let's say a flag's used to provide AI configuration. When the user encounters that feature flag, we go to the next step. The flag system determines which configuration to retrieve based upon the targeting rules. Like, do you get A, do you get B? Do you get the reduced tokens, or do you get the sort of standard deployment? And then basically the idea is that events are ingested for that user. Basically, if you have the user and you know what they saw, and you have the events that they saw, then you can compute the metrics. Then you can prove causality, right? But you can't do that based upon just upon sort of this combined data, because users have seen different code is executed for different users, for example. So you basically have to compare the users who have seen a certain feature and compare the metrics for those who entered the experiment versus those who didn't, right? And you can do this for each individual feature flag. And so that's kind of how you need to think about attributing events to users who have seen certain features, and sort of experimentation in a world with feature flags and multiple features kind of being deployed at the same time, or kind of multiple experiments at the same time. It's not a trivial problem. And so here's like sort of an example, right? So metric performance of individual features can be different from performance of your system on the whole, right? So it's important to keep that in mind. It could be that cart size is increasing because of a flag 2 change, or because of a flag 1 change that was just delayed as part of it took a while for it to affect users. So it's just, again, something to think about here is that if you're running multiple experiments, like you have multiple feature flags at percentage-based rollouts, it can be difficult to determine why something is going on, unless you're actually sort of computing individual metrics for those feature flags for those users who saw those certain treatments. All right, so now we can look at some examples. So training for a neural network, parameters for a neural network can be stored in the feature flag system as well. Here's like the number of epochs, like the number of times you're iterating through. Again, this is Python. So get treatment with config here. Number of epochs, change it to json.loads for those who are using Python or familiar with it, and then just get the number of epochs out of the feature flag parameter store, and then pass that into the function. Some other things to think about: if you're training a neural network, you can change the activation function. Which one do you activate the neuron in your neural network to use the sigmoid or not? Or here's a kind of a bigger one. This is a retrieval augmented generation. Again, sorry for the lot of code here, but I've just kind of got arrows to the things that I want you to put your eyes to. So I know there's 4 of these, but like I'll go through them. So here in the case, we're using individual flags for individual parameters, right? So use more text chunks, right? So in a RAG system, like a retrieval augmented generation, you basically take the question and you augment it with actual text from your system. In this case, basically you take the question, or the first thing you do is you take your text that you want to augment your AI system with, and you embed it with basically taking chunks out of the text. You vectorize those and you compare those to the question and get the ones that are closest to it and add those as context to your question or to your answer, to your prompt to the generative AI LLM. And what you do here is you can say use more text chunks or the GPT model, and you can basically control that from your system as well. And another stable diffusion example here, it makes simpler prompt or make smaller image. Again, just ideas that you can think about. And so for the future, things to think about here as well. Real-time parameter adjustment. There's something in some feature flag systems called multi-armed bandit. For those of you who have or have not sort of walked down the experimentation branch of feature flagging systems, multi-armed bandit basically is where you release a bunch of variations into the wild, and the feature flag system sort of automatically chooses the winner. But there's sort of even more advanced version of that, which is where like you can actually, you might want to change, have the parameters changed for the next iteration of the experiment, and that's like stuff that's potentially ongoing research, like goes into more AI-driven flag management, like optimizing flags and handling tech debt. So for those of you who are familiar with Uber's Piranha project, which is sort of an open source tool to reduce tech debt in systems, which is pretty cool. So take a look at Uber's Piranha as well. Automation of flags through CI/CD pipelines. That's also something that's interesting. Basically, releasing a feature and have it automatically behind a feature flag in your CI/CD pipeline. That's something that we're working on at Harness, which is going to be really cool. And community and industry collaboration. For those who have used feature flags a lot, you might be familiar with Open Feature, which is sort of a CNCF, the Cloud Native Foundation's feature flagging, open source feature flagging sort of interface, which is kind of neat. I've played with that. So I think that's it. So I'm at Twitter at Klein Joshua A. I don't and refuse to call it X. And I'm also on LinkedIn as Joshua A. Klein. If you ever come to Michigan, Detroit, come say hi. And that's it.